Okay. This is the advanced manufacturing processes. Okay, MEC 350C. This is the 4 credit course. Okay, and today we are just discussing about what is the syllabus content. Okay, means introduction about the advanced manufacturing processes. Okay, so okay, start. Okay. So first, there are like a total 5 unit in this subject. Okay. So first unit will be like advanced, as it is an advanced manufacturing process. So all the units will be like named as a advanced. Okay. So first is like advanced machining process, because in third semester also we have studied, and I already taught that subject to you, in which basically we studied about the different types of the machining operations, especially machines involved. Okay, and the basic of the metal cuttings that were involved. Okay, so that we have discussed in the machining processes. So this unit is related with the advance. Okay, what is advance here is, or these processes also we can say like non-conventional machining operations. Like why we are calling it as a non-conventional, reason is like in the third semester we started with the men's material welfare. Just I'm reminding you to recap all these things very early within a few minutes. So we started in third semester, we started with the man's material welfare, that what is the need of the machining operations or the manufacturing technology. Okay, why we are starting that part. So we started with that, and we discussed the men's material welfare, the manufacturing needs, and that concept, the concept and principle, and the purpose of the machining operations. Then we started with the metal cutting part. Okay, metal cutting, in which we can say like mechanics part. Okay, in which basically we discussed about the R, which is a chip thickness ratio, phi, this is the shear angle, alpha, that is the rake angle. Okay, we also derived the relationship between these three. Okay, and we studied about the relationship between the V, that is a cutting velocity, VC, that is a ship velocity, and the VS, that is a shear velocity. Okay, all of you are aware, just I'm reminding you that it will be easy to understand for you guys. Okay, so that we have studied in the mechanics part. We also studied that there are different types of the chip formation. Okay, when we are using the different types of the materials. Okay, so when there is a the chips are like continuous, discontinuous, and the continuous chips with the build-up edges, and that depends on which material we are using. Okay, if we are using the material like ductile, then we say that this is a softer material. Okay, so there is a continuous chip form, as well as the continuous with the build-up edges chances there. Okay, and if we are taking the ductile material, which is very hard in nature, so that for that the discontinuous chips will be formed. Okay, because initially when there will be a chip is formed, as it is a very brittle, so the material will come out from the workpiece. Okay, so the discontinuous chips will be formed. Apart from that, we have studied about the merchant circle diagram, MCD. Okay, that in the third semester. Okay, so this is the merchant circle diagram, and in the merchant circle diagram, we discussed about the different types of the forces. Okay, there are total 6 types of. Mainly, there are 3 forces. That is FC, that is a main cutting force. F, that is a frictional force, and the FS, that is a shear force. And perpendicular to these three, there is a perpendicular to FC, that is a FT, that is a thrust force. F is the friction normal to that, that is N, and Fs, that is a shear force, and normal to that, that is Fn. Okay, so these 3 forces are perpendicular to that. So these chemistry of these 6 forces, okay, or mechanics of these 6 forces, we have studied in the merchant circle diagram. Okay, on the basis of that, we are also using the relation angle of like phi, alpha, and the beta. Beta is, again, there is a friction angle. Okay, so on the basis of these combinations, we derive the relationship between these forces. Okay, so that we have studied. We also studied about the tool life and the tool wear. Tool life and tool wear. Okay, so in which basically we derived the Taylor's tool life equation, Vt raised to n equals to constant, where V is the cutting speed and T is the time. Okay, tool life we can say, N and C are the constant. Okay, apart from that, we also studied one more Taylor's two life equation, that is Vt raised to n f raised to a and d, that is just to b equals to c, where this is the modified Taylor's two life equation, which is in which f is the feet, okay, mm per revolution when we are talking about the operations that we are working on a lathe machine, and d is basically, small d is basically the depth of cut. Okay, so that we have studied. Apart from this, once after this, we studied about the economics of tool life, in which we studied about that how the cost, like tool cost, tool grinding cost, machining cost, all these will be affiliated with each other. Okay, so that that we had discussed. Now after that, we studied about the this is up to the third unit. Okay, after that, in the fourth unit, we studied about the different types of the machining operations. Why I'm calling it as a machining operations or the machining processes, because in which the machine is involved. Okay, and if I simply say that what basic machining operations are available, so we can say that is a lathe is available. Okay, in which we can perform number of operations. Okay, drilling is available. Okay, milling is available. Grinding, we can say. Okay, and the shaper, these are the common, and these are basically the conventional machining operations. Why it is conventional? Because conventional means here is the complete mechanical engineering is involved. If you talk about the lathe machine, then complete whatever the work we are performing or any operations we are conducting, there is a tool and the workpiece. Okay, so there is a contact between these two. So whatever the material is removed, that removed due to the contact only. Okay, so that we can say that whatever the material removal processes occurs is due to the contact of the tool and the workpiece. So that is basically the conventional machining operations. If not only lathe machine but drilling operation, same drill bit is there which is rotating and we are giving a feed to that. Okay, and there's a workpiece, so we are inserting this drill bit inside that. Okay, milling operations, there are two types, there are different types of the milling machines. There are different milling machines means like the horizontal milling machine, vertical milling machine, universal. Okay, simplex bed type, duplex bed type, triplex bed type, that also we have studied. Okay, and on the basis of like what cutter we are using, whether this cutter is a like planer, like simply simply we can say like grinding wheel, it's a kind of wheel on which periphery of that there is a teeth are there. Okay, so that will remove the material. Fine. And like end mill cutters are also there, which is mounted perpendicularly. So that we have studied. We also studied on the combination, based on the combinations of types of the milling machine and the types of the cutters. That is types of the operations, that whether we are using a up milling, down milling, gang milling, straddle milling, that we have studied. Okay, previously in the third semester. Grinding also we have discussed. Grinding, similarly there is a grinding wheel we are using, and if we have to remove the material, either we have to move the workpiece toward the grinding wheel side, or we have to move the grinding wheel toward the workpiece side. Okay, shaper, that also we have studied. Okay, so all these, if you will see these combinations in which basically the material is removed due to the combination of the due to the contact of the workpiece and the tool. Okay, so that's why we are calling it as a conventional part. Now after that, in the fifth, this we discussed in the unit number 4 in the third semester, machining operations. Okay, now fifth unit, in which we discussed about the different types of the finishing processes. Like these finishing processes involve the honing, lapping. Okay, and the super finishing processes are there. Grinding is also a kind of finishing process if the abrasive size is very small. Okay, so that we have studied in the machining operations. Okay, so just I am reminding you these things, that what we have discussed previously, as it is a manufacturing part, and this is last. Like, okay, there are three subjects of the manufacturing. In the third semester you have studied about the machining process. In the fifth semester you have studied recently about the manufacturing technology, and this is the final and last manufacturing subject, which is a advanced manufacturing processes. Okay, now this advanced is based on what we have you have studied previously. So this first unit, Let me check through this. Sorry for this disturbance. Actually, it's okay. Okay, so why discuss this machining processes part? Because this first unit, okay, that is based on the advanced machining operations processes, or we are also calling it as a non-conventional machining processes. Now, some of the books you will find out that these are written as non-traditional machining operations. So that is also fine. Okay. Now, why we are calling it as a non-conventional? Because as I said, that in conventional there is a workpiece in the tool, contact were there, and whatever the material is removed due to this contact only. Okay, but in this non-conventional machining operation, there is no contact between the workpiece and the tool. Okay, as well as these processes, these why we are calling as the advanced, because uh, this material is removed in these operations is not due to the mechanical. Okay, till now what we have studied previously, that is material is removed due to the mechanical operations, but in these processes the material is not removed due to the mechanical operations. Okay, now how the material is removed, so that I'm just briefing that one. Okay, now, first of all, we will start with the chemical machining of, operations in the next class. Okay, that is our first operation, chemical machining, and this is the first operation. And if we talk about this next operation, that is the electrochemical machining operations. So both these operations, in which basically the chemical machining is involved, means the chemical energy is involved. Machining is like which kind of energy we are using, or what kind of work is done on the tool or the workpiece. Okay, by the tool on the workpiece. So which type of the energy we are using here is in this, basically to remove of the material we are using, to removal of the material we are using chemical energy. Okay, so that we will study in the chemical and the electrochemical machining operations. Then we will study about the electric discharge or electro discharge machining operation, that is EDM. Okay, in which basically the material is removed due to the discharge, electrical discharge. Okay, so this is also like material is not removed here, is also due to the uh, mechanical operation, but the material is removed from due to the electric discharge. Okay, then we will study about the ultrasonic machining operations, in which basically we will use the abrasive slurry. Okay, and how the material will be removed due to this abrasive slurry. Okay, so that is important. Next is we will discuss about the concept of the thermal energy. The thermal energy. Okay, so if we talk about the laser beam machining, electron beam machining, and the ion beam machining. Okay, in which basically the beam of a concentrated photon or electrons we are using. Okay, so that is like these electrons and the photons which are moving at very high velocity, we can say that that have a very high kinetic energy, because kinetic energy is what, like half mv square. Okay, so if any particle which has a very high velocity, we can say that it has a very high kinetic energy. So this kinetic energy is converted into the thermal energy. So these are basically the example of how the kinetic energy is converted into the thermal energy. So all these like LBM, laser beam machining, EBM, electron beam machining, and IBM, that is ion beam machining, is based on the thermal energy consumption. Okay. Next, after that, we will study about the abrasive water jet machining as well as abrasive jet machining. Abrasive jet machining. Okay, AJM. Fine. Like so in this basically like jet machining, it's a kind of jet machining. Okay, in which basically here if we are talking about the abrasive water jet machining, then we are using the abrasive particles along with the water. So we can say like we are using a slurry, but the abrasive particle composition is lesser than the water in that slurry. Okay, that only it will flow. otherwise it will be a solidified material. Okay, in the abrasive jet machining, same, it is abrasive jet machining we are using, but here is only the abrasive particles. But not only the abrasive particles, here there we were using the abrasive water jet machining, here it is like abrasive jet machining. But jet we have to create. Jet means what? Very high velocity. Okay, so how we will create this very high velocity? Either we can use the water. So there, in that abrasive water jet machining we were using the water. But if we have to flow the abrasive with a very high velocity, what we have to use, what the other fluid we can use? Gases or air, we can say. Okay, so here basically we are using the gas to create the jet. Okay, so this high speed gases are connected, mixed with the abrasive particles, and they will basically impinge over the workpiece surface and remove the material. Okay, so this is basically the different types of the non-conventional machining operations that we will study in that in the uh, first unit. Okay, next is, okay, next is related with the advanced, related with the casting processes. Okay, so as I said that all the units that involve the advanced, okay, reason is whatever you have studied previously, that was basic, and now what you are going to study in future in this semester, that is advanced. Okay, so in the casting processes, if I simply say, in recent fifth semester only you have covered that part, and just I'm briefing you to remind all these things or recap all these things. By the way, recently you have completed, so you are aware about these things. So in the casting, basically you started with the like different types of the elements are there. Okay, so first, like we can say that there is a pouring basin is there. Okay, so can you write the in the chat box that what are the elements are there? So it will be like I just get an idea that hope you are aware about these things. Okay, so can you write in the chat box? I'm just waiting for 2 minutes. That what are the other elements that you have studied in the casting processes? Cope, drag, very good. Cop and drag are the part basically in which we are making the first of all we are mixing the sand. Okay, and then we are inserting the pattern inside that. Okay, so whatever the shape is formed, after that we are removing that pattern and mix, lapping over one over each other, and then we are filling the material. Okay, very good. Sprue, riser, very good. Drag, right. Skim bob, right? Gate, in gate, right? Chaplets, riser, very good. So can you, all of you are right, right, very good. So can you tell me one more thing that if there are two parts, okay, for the casting, then there is a cope and the drag we are using. If there are three elements, then what will be the name of other third one? Like three elements means bottom part, top part, and in between there is a third part. Okay, so what is the name of that? Can you tell me?
Core.
No, 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 no. Cheek, right? Core is not that. Core is basically the if you have to create a hollow cavity, then that time we are using the core. Okay, cheek, right? Asif is written that. Cheek, if there is a three elements, then we say cop, drag, and the cheek. Okay, third one element. So all of you have written very good, like chaplets and riser, side riser, runner, cheek, all these things. That great. So we started with this one. Okay, you have started with this elements, that is pouring basin. After that there is a sprue. Okay, then sprue, then there is a runner. Okay, and after the runner there is a gate. Okay, and then there is a mold cavity and all these things, and in between there is a core is also we are keeping. Okay, so now if we have to create the hollow cavity, that time we are using this core, and this core is generally made up of the sand. Okay, and sometimes we are also using the chaplets. Okay, so chaplets, why we are using the chaplets? Because if we have to hold any cavity, okay, or the whole decor, like अगर मान लीजिए कि ये आपको इस तरह से fill up करना है, like okay, like here you have to create something, okay, hollow part. So how you will hold that one, okay? So what we have to do is we are using the chaplets. Now this chaplets is basically these are the, मान लीजिए कि इसमें आपको ये जो material है, you have to fill the aluminium, okay? Then the chaplets is made up of the same material, okay, and this is hold it with this side as well as the core part, okay. So what will happen that is you will fill the material from this side, it will fill inside this one, okay, completely, and whatever the grade of specific grade of this aluminum if we are using made these chaplets with the same grade, okay. So after that, basically after the casting is done, these chaplets will become a part of this casting, okay. You cannot remove that part, so try to make the chaplets of the same material of the casting, and generally ऐसा होता भी है, right? So these are basically the basic elements of the casting. After that, you have studied different types of the gate like top gate, bottom gate, and time calculation part. I hope that you also discussed that one and numerical problems. And like you have studied about the different types of the saints, okay, different types of the saints, different types of the binders, and what is the combination of the, like for an example, moisture sand, moisture we are using, or the green sand or the loam sand, that you have studied different types of the saints, as well as you have studied about the different types of the properties, like what basic properties are required, okay, like we can say that permeability, collapsibility, and there are different types of other flowability, okay. So these are basically the basic properties that I hope that you have studied about that. One more thing that you have studied in the casting, that is the different types of the allowances, okay. This is shrinkage allowance, okay, solidification. So these things like taper section is also required, so that you have to provide the draft is there, so that you have studied, okay. So in this, basically we are not going to study the that these things, because that you have already studied. Also one more thing, like you have studied the basic casting operations, like centrifugal casting, okay, slush casting, investment casting operations, okay, so that you have studied. So little bit like here if we talk about the okay. So here, like if we talk about the metal mold casting or the continuous casting, these are nothing but the similar process like basic casting processes. Okay, so like simply what we are doing is like we have like cope and tray part, then we have filled the sand, in which basically we kept the pattern and the shape is formed. After that, remove that shape and fill that pouring basin is there. So start filling the material into that, and that will come out, and once it is filled throughout, it will come out the riser. So that basically these two processes are related with that only, okay. This concept sketch casting is also similarly, it is well it is with that, but like vacuum casting or evaporative casting if we talk about, then the evaporative casting and ceramic shell casting, okay, these two processes are little bit it's same like the investment casting, okay. Investment casting, like in the investment casting you were making the pattern of the wax, okay. So here it is like here we are using the evaporative pattern, so here also we can use the wax, because wax is what, like when the hot material, molten material which is at very high temperature, that will come in contact with that wax will not only melt but it will evaporate, okay. Reason is because very high temperature is coming in contact with this one, okay. Similarly we will discuss in the ceramic shell casting little bit. The different is vacuum mold casting. Reason is whatever the there are two things. First is vacuum casting and the vacuum mold casting. There are two different processes, okay, that I will brief you in that classes. So please keep in mind that here we are using the vacuum, okay. Like if we are creating a vacuum, it means that we are creating a negative pressure. So if we have to create the negative pressures, it means that we have to use the different types of the pump, so that will create the negative pressure, okay. So that we will study. So that's why this process, vacuum mold casting process, is little bit complex as well as very costly. So this happen. Generally, we are using wherever there is a costly part we have to prepare. Okay. So this we will study in the advanced casting processes. Okay. Next is advanced welding processes. So you have studied about the welding processes recently. So I'm just briefing what you have studied. So you have studied. Okay, can you tell me the what are the operations that you have studied recently? Especially just write a simple term, okay, or abbreviation also you can write like shielded metal arc welding, SMAW you have studied. Apart from this, gas welding, right? Gas welding. I hope that you have studied about the gas cutting as well. Take okay, take Majid, right? Take MIG you have studied, right? Right. So these are operations, and I hope that all of you are aware about these things because okay. So I'm just briefing here. If we talk about the advanced hydrogen welding, okay, I think Sir has also discussed about this one, these processes, and also you have studied about the advanced, sorry, plasma arc welding. So plasma arc welding and the atomic hydrogen welding, these are nothing but related with the advancement of the TIG. TIG is basically the tungsten inert gas, or we can also write it as a GTAW, that is a gas tungsten arc welding. Okay, so in which basically we are using the tungsten electrode. Why we are using that one? Because it has a very high wear resistance properties at very high temperature, or we can say more than 2500 degrees centigrade, it will not wear out. Okay, so 25, about 2500 degrees centigrade, it will not wear out. Okay, so TIG, it is these plasma arc welding and the atomic hydrogen welding, just the advancement of this TIG. If we are using a different kind of nozzle or advanced nozzle in which the ionized gas like argon, neon, and CO2, or helium, we can say, if we are using that one at a very high velocity and large compound, then we can say that there is a bombarding of the electrons over the workpiece surface, so that will basically remove the material. So we can say that is basically the plasma that will form the plasma. And on behalf of using single electrode, single tungsten electrode, if we are using two different types of the electrodes, two, not two different types, but two tungsten electrodes, okay, at the same in a same process, then we can say that there is a atomic hydrogen welding. Okay, so that is also a kind of advancement of the TIG. Okay, so that we will study. Like here, some these processes like ultrasonic welding and laser beam welding and the electron beam welding. This is little bit related with the machining operations. Okay, so now what is the difference between machining and the welding that you have studied already? Machining, in which basically we are removing the material. Welding, in which we are joining the material. Okay, so where machining can be done is like if it is a like one material. Okay, if it is a one workpiece and there is a tool, so we can remove the material. Okay, or like we can say if we are talking about the electron beam, then there is a bombarding of this electron over the workpiece surface, and that will remove the material. So if the material is removed, okay, so just keep it. We want a pre-recorded lecture on GC. Ibad, yeah, sure. Not pre-recorded, but whatever the things that we are going to discuss in these lectures. Okay, these lectures I have recorded, so I will most probably I will upload on the YouTube after 2 3 classes, and I will share the link of that. Okay, so no need for that.
Thank you, sir.
Fine.
Thank you, sir.
Okay. So like machining is like these are the like single if you are this is a single workpiece, we can say, and there's a tool, or if you are talking about the EBM operation, then bombarding of the electron over the workpiece surface, and that will remove the material. Okay, so like this is the machining. But like for an example that these are the two different types of the material, and like if we are bombarding and at the edge of these two, okay, so like these are the two materials and we are bombarding over this surface. Okay, so what will happen, that will remove the material from this area. So if the material removed from this area, it means that some amount of the material is removed from this side as well as this side. So what will happen, when there is a solidification is takes place, the material will combine each other and that will basically become solidified, okay, or that will become solid. So joining is takes place. So this is nothing but a little bit amount, like ultrasonic welding machining and ultrasonic welding. So little bit amount of the change of the energy only, that for the machining we are using high amount of the energy, and for the welding we are using less amount of the energy, or some have somehow different, that depends, okay, on the operation. So similarly in the lbm, or like we can say lbw or ebw, okay, rest process is same, okay. Okay. Next is the advanced metal forming operations. So, metal forming is like a sheet metal operations only. Like, if we talk about the sheet metal operations, that what you have studied, like if we are talking about the bulk operations, okay, and this can be classified, like sheet metal operations can be classified in two categories. First is like bulk deformation, and secondly it's like a small amount of the material is removed. So if we are talking about like bulk material is removed, bulk metal is formed, then we can say like can you tell me that what are the operations in which, if we say that there is a bulk deformation is takes place in the sheet metal operations, then what are the operations? Can you tell me? Hot rolling, right? Rolling operations, right? Rolling operations, extrusion we can say, okay, extrusion we can say, wire drawing operations we can say, because there's a bulk deformation is like one more example, like forming operations, okay, forging, sorry, forging also we can say, because there is a solidified material is there and we are impinging the work force on that, pressure on that, okay. So that is also the yeah, forging, Razi, right, Majid? So these are basically the bulk deformation. Can you tell me the small amount of the deformations? The operations of the in which the material is removed in a very small amount. These are the operations: hot rolling, forging, wire drawing, extrusion. These are the operations in which the material is removed in large quantity. Okay, that's why we are calling it as a bulk deformation. So, can you tell me the example of where the material is removed in less forging and cold rolling? We can say, Aman, like, but forging is an example of bulk deformation.
I'm talking about cold forging. We do not heat the materials.
Forging is but in a small deformation, if we talk about, then like uh, we can say like spinning. Spinning is an operation in which very less amount of the material is removed. Spinning as well as deep drawing. Okay, deep drawing, I think you have studied, in which basically we are deep drying is kind of like operations like in which we are taking a small thickness sheet, and there is a plunger is there, okay. So like what we are doing is we are applying a force on that plunger, and these things are kept on a dies, okay. So that will basically insert inside that. And I think I hope that you have studied about the punching and the die operations, okay. So that is basically the deep drawing operation. So I hope you have studied these things. So these are in which basically the less deformation is occur. So Okay, so here in this, like we are going to discuss about the advanced metal forming operations. So advanced is like these are different from that, and here basically we are using the explosives. Okay, so explosives as well as the high amount of the energy that is generated either by the magnetic operations, means either by the magnetic operations or the electromagnetic operations, the combination of electrical energy and the magnetic energy. Okay, so if we are talking about the high energy rate forming operations, okay, or explosive forming, here we are using a high amount of the explosives to basically that will explode, and like there is an explosion, and here's a workpiece, and there's another workpiece. So if we have to basically impinge, this is basically the workpiece, and sorry, this is the workpiece and this is the tool. So if we have to create a chain shape over this workpiece, then we will keep this tool over the explosion. Okay, so once the explosion is takes place, it will basically take a very high velocity, and that will basically impinge over this workpiece surface. Okay, this is basically the principle. Okay, so this kind of principle is these two, like high energy rate forming HERF and the explosive forming, that is based on these concept. And here electromagnetic, like we are using the energy combination of the electric and the magnetic field. And here electrohydraulic, like electrical energy by using the oils. Okay, so that due to which the forming is takes place. So that we are going to study in this. Okay, so this part is very easy. Next part is basically the advancement, but this is the advancement of the manufacturing technology only. Okay, what we have studied till now, like when I taught you the machining operations, in which basically I classified the machining operations in a three types, three groups, in which first, in which the material is removed, means material will be same. Okay, there will be zero change in the material. I hope you are aware about these things. Negative material removal, like negative kind of process and the positive kind of processes. Zero processes, in which basically we are talking about the example like casting, forming. Okay, so these are basically based on the zero, means whatever the material you have, you are just changing the shape, rest is everything is same, means total amount of the material or the volume is same throughout the process. Okay, if we are talking about the negative operations, then we can say that machining is the best example. Okay, machining in which the material tool will come in contact with the workpiece surface, and that will remove the material. So if we talk about the workpiece, then finally the material, the volume of the material is removed, the workpiece surface. And if we have positive operations, then we can say that we are talking about the welding part, in which the material is already there, two workpiece material are already there, and if we are depositing the material, means if we are depositing the electrode, if we are welding it, then the material will be deposited over the workpiece or surface. So that is a positive kind of operations. But in the rapid prototyping and the manufacturing, there is a new, this basically a new types of the machining operations, or not only the machining, yeah, machining operations we can say, or manufacturing processes we can say, in which basically whatever the shape is required, okay, you should make it accordingly. Okay, it means that like there are different types of the operations that we will study. So like basic is like, simply I'm just writing that is 3D printing operations. Okay, 3D printing, or we also call it as a FDM. Basically this is based on the technique which is a FDM, that is a fused deposition modeling. Fused deposition modeling. This is a simple one technique. There are a number of techniques are available. So this is the one technique. Okay, so this is based 3D printing, which is based on the FDM technology. So in 3D printing, what is 2D printing? 2D printing is like जो भी आप notebook pages पे notebook पे लिखते हैं, that is a kind of like you are editing something. Okay, means you are, there's a blank page is there and you are writing over that. Or in other words we can say like आपके पास printer है, तो आप printer में से print out निकालते हैं, तो single side like you are writing something, you are writing something, it means that two dimensionally you can write x and y direction. Third dimension is like perpendicular to that page. Okay, so if this is a page, then I can write in this direction, as well as if one this line is completed, this para is completed, I have to move in the downward direction. Okay, But three-dimensional is like I'm moving over this plane, मतलब perpendicular to this plane. Okay, so this is basically a three-dimensional printing. Okay, so that's why we are calling it as a 3D printing. So in which basically the material is not only removed, मतलब remove तो नहीं होता है, ठीक है, we are just adding the material as per the requirement. Now how we can do that? So that is that we can do that first of all we have to create the CAD model. Okay, that there are different types of the operations or the softwares are available like CATIA, ProE, SolidWorks, Creo, Fusion, AutoCAD. AutoCAD generally used for the 2D operations, but 3D can also be possible. 20% part of that, so that is also can be possible. So these are the operations through which basically we prepare the CAD model. ओके एंड आफ्टर दैट दी लाइक जो भी आप 3D प्रिंटर यूज कर रहे हैं जिस भी कंपनी का लाइक दे एवरी कंपनी हैज देयर ओन सॉफ्टवेयर टू कन्वर्ट दिस CAD model. Okay, now after once the CAD model is prepared, after that we convert that into STL format. Okay, STL is a format basically that is the language that is read by the 3D printer. Okay, that is the language. STL means it's a standard triangulated language. Okay, so that is a STL format. We whatever the shape 3D shape you have created in the SolidWorks for an example, so you have to convert that into the STL format. Okay, and that STL format is nothing but that will create in a very small triangle. Okay, like if this is a line, okay, that we have to create, so that will basically create these kind of triangles. Okay, so these kind of triangles will be created on the particular line or particular surface we can say, and that will be created. Okay, that triangle will be created, and that will like slicing over, like एक layer हो चुका है, then it will be another layer, then third layer, then fourth layer, like this. Okay, so it's like a slicing process. Okay, so that will basically convert this 3D printer will read this STL format, so you have to convert that one using that software. Particular different types of the softwares are available for different types of the companies of these 3D printers, so that is available. So we have to convert that, and that will then there will be a 3D printing. So for that, what is the needed? The material. What kind of material till now is we can do, we can go for a PLA. Okay, we can go for the ABS. Okay, or like we can go for the nylon as well. Okay, because whatever the range, if their range is below 450 degree centigrade, then these kind of material like melting hota hai and initially it fused ho jaye. That's why we are calling as a fused deposition modeling, that whatever the melted material as it is coming out from the nozzle, immediately it should be solidified, or in other words we can say that immediately it is fused. Okay, so that's why we are calling it. So if it is below 450 degree centigrade and immediately it is coming out and it is fused, then we can use that material. Okay, till now the application is available for that, and we have created these 3D printers. People are also working on the 3D printing of the metal part. Okay, metal parts. Okay, like these type of operations is generally many professor in the IITs, they have they have covered this metal, that how the material can be removed. Okay, so that also I will try to discuss once when we will study about these operations. Okay, so this is all about from my side in this advanced machining operations or the subject discussion part. Okay, so if you have any queries, I think uh, but still you have any queries, I think generally you do not have, because it is just an introduction part, but still you have, I'm giving you 2 minutes so that you can ask me, or by that time I'm right, I'm just taking a screenshot of your attendance. Okay.